Before you start watching this video, make sure you have a calculator handy. We're going to want it for this video. So once you get your calculator, what we're going to be doing is we're going to be computing limits numerically. We're actually going to have three different methods for computing limits. So we've looked at limits graphically, where we're given the graph of a limit and we can find the limit. Now what we're going to do is we're going to take like a function and we're going to compute limits numerically. And then in a couple of class periods, we'll compute limits algebraically, which is going to be our best method. So with graphical limits and numerical limits, we are estimating things, but estimates are useful. So that's what we're going to do today. So let's compute this limit that I have here. This is one we saw in class last time, actually, but we're going to compute it numerically. What we want to think about here is remember that when we're computing a limit, what we're asking is, what is this function doing when the x values approach a particular number? So in this case, we want to know, what is this function? What is this function doing as x gets closer to 2? Okay, we don't care what happens at 2 itself. And in this particular problem, if we plug 2 in, we get an error because the denominator is 0. But we just care what happens very, very close to 2. So what we're going to do is we're going to plug in numbers close to 2, and we're going to see if we can figure out what the y values are doing. So let's pick our favorite values that are close to 2. And I'm going to plug those in for x into our function. So numbers that are close to 2, I'm going to put 2 here. I'm going to put a dash there because I can't plug 2 in itself, but it gives me a good dividing line. So let's plug in numbers a little bit smaller than 2, and we're also going to plug in numbers bigger than 2 to make sure that the limit actually exists, that both sides do the same thing. So numbers bigger than 2, let's do like 2.001, 2.01, and 2.1. Notice that in this direction, the numbers are getting closer to 2. So 2.1 is bigger, 2.01 is closer to 2, 2.001 is even closer to 2. Okay, let's pick numbers a little bit smaller than 2. Let's try like 1.9. 1.99 is a little bit closer to 2, and 1.999 is a little bit closer to 2. We usually pick numbers like this, 0.001, 0.01, 0.1, and then 0.999s. That usually works well. So as we kind of move into the middle of this table, our x values are getting closer to 2. So as we move into the middle of our y values, we're going to say, what are those y values getting closer to? Okay, so now I need to plug these x values into my function, and that's where a calculator is going to come in handy. Let me go ahead and I'll show you a nice way to do this in a graphing calculator, and then we'll interpret our results. So let's pull up my virtual calculator here. So hopefully you have that worksheet pulled up as well. I'm going to go ahead and I'm going to type my function into the y equals. And it's always clunky when I do this from my computer, so have patience with me. So let's make sure we put our numerator and denominator both in parentheses. So I have x minus 2 over x squared minus 4. Definitely make sure you have your parentheses there, otherwise things will be divided incorrectly. What we're going to do now is we're going to go to the table, but I'm going to make my life a little bit easier. If I go to second table set, I'm going to choose the independent variable. I'm going to choose that to ask. If you do this once, then your calculator will keep it in there. So we probably just have to do this once. And then we go to second, and graph gives me my table. Notice there are no x values in my table right now, and that's because I changed that to ask. So now I'm going to type in those x values that I have in my table. So I had that's not what we had. We had 1.9. We had 1.99. 1.999. Remember, these are my values for my table. I'm going to put 2 in. Notice we get an error there, which was why I put the dash line by 2, and then 2.001, 2.01, and 2.1. Okay. So in order to compute the limit, what we want to do is we want to look at these y values. We're asking ourselves, what are these y values doing as we get closer to 2? So these y values up top look like as I get closer to the x value of 2, they're getting closer to 0.25. 1/4. And in the bottom as well, as I get closer to 2, these numbers look like they're also getting closer to 0.25. So since both sides seem to be approaching 0.25, we would say that our limit approaches 0.25. Okay. And the work that I would want you to show for that on your paper, I don't want you just to type this into a calculator. I want you to write that table down. So I'm going to try and copy this down quickly. So the 0.2564, 0.2506, 0.2501, these are the numbers we got in our calculator. Okay. 0.2439. Okay, so we're asking ourselves, what do these values get closer to? They get closer to 0.25. Since both sides get closer to 0.25, we say that that's our value of our limit. Remembering once again that this is just an estimate, but it's a good estimate and it turns out to be exactly the correct answer. Okay. One thing what we're doing here is that this top half is giving us the left-hand limit. So this is really telling us, if I just looked at the top half of this chart, I would be saying that the limit as x approaches 2 from the left-hand side of this function, and I'm just going to write f of x here, is equal to 0.25. And that's because those are the numbers that are less than 2. And then this half is telling us that the limit as x approaches 2 from the right, that's from the right because the 2.001 are bigger than 2. That this limit from these numbers over here is also 0.25. And from last class, we saw that since the left and right hand limits match up, our overall limit is also 0.25. Okay. So let's use a table of values to compute this next one as well. Why don't you look at this and try it on your own before you watch my answers? But if you're ready to go ahead and start working and have tried it, we notice that this one's just a right-hand limit. So I just need numbers that are a little bit bigger than -1. So this guy is my function here. Actually, notice that t is my variable. So I'm going to have t and f of t. I want numbers that are a little bit bigger than -1, which means a little closer to 0. So numbers that are closer to 0 than -1 would be like -0.9, -0.99, -0.999. We notice that these numbers get closer to -1. So when we look at our y values, we're going to be asking as we go down the chart here, what do they get closer to? Okay. And so let us put this back in our calculator. So once again, you should try this. So I'll share my screen. So I'm going to go back to my y equals, and I'm going to change my function. That function was a really messy one that we had. We had 2 minus the square root of, notice that on my paper, I had the variable t. It's much easier just to use x in your calculator, and that's what your calculator is expecting you to do. So just change it to x, and that's okay. Square root of x plus 3, go over, close my parentheses. Oops, not multiplication, I want division. And x plus 1. Once again, make sure you have those parentheses both in the top and bottom. Otherwise, your calculator is not going to be dividing correctly, and you'll get the wrong answers. And then let's look at the table. Remember, I'm going to second graph to get to the table. I'm going to just have to replace these numbers now. So just on top of that 0.9, I can type in my -0.9. Notice I'm using this negative button down here. That's the one that the calculator expects as a negative. This one it treats as a minus. I'm going to do -0.99 and then -0.999. Okay, and so we can forget the rest of this table. You could just clear those if you really want to, or delete them, I guess, if you really want to get rid of them, but you don't have to. So we're asking, what do these numbers get closer to as I move down the chart? They look like they're getting closer to 1/2. If you can't tell that, go ahead and type in another number like -0.9999. And ooh, that rounds exactly to 1/2. So it does indeed look like these are getting closer to 1/2. So we would say that that limit for that second problem was 1/2. That's once again our estimate. It's not an exact value because we don't know how to compute exact values, but the table of values give us good estimates. Okay, and let's do one more example for this video. So go ahead and try this one on your own. The limit as x approaches 0 of 1/x⁴. Notice that this one is not a left or right hand limit, so I'm going to put 0 in the middle. My function is 1/x⁴, and I need numbers both bigger and smaller than 0. So numbers bigger than 0 are like 0.001, 0.01, 0.1. Notice as I move up, these numbers get closer to 0. And now as I move down, I want numbers that get closer to 0. So numbers that are on the left-hand side of 0, a little bit smaller than 0, are negative. So this would be like -0.1, -0.01, -0.001. Numbers close to 0 are a little bit weirder for students, strange sometimes. So now we want to plug these numbers into our table of values in the calculator. I'm going to let you do that and see what you get. And it actually looks like I didn't even type these in, so I'm going to just leave those off. I think we get enough information with just 2 values here. So when I type them in, I got 10,000. I get 10e8 here, which is 10 to the 8th power. Sorry, I actually got 1e8, which is 10 to the 8th power, because 1e8 means 1 times 10 to the 8th. And then let's see, 0.01, I get 1e8 again, so that's 10 to the 8th. That's a big number. And then I get 10,000 here. So these numbers look like they're getting bigger as my y values, as my x values get closer to 0, my y values are getting bigger. They're getting bigger and positive on both sides. So we say that this is infinity. If you look at the graph of this function, x to the 4th, it looks like this. You should look at the graph on your calculator. So graphically, we would expect that to be infinity as well.